All right, so good afternoon, everyone. Thank you so much for joining in today. And but today we are going to learn how to write unit test in C Sharp. My name is Dhananjay Kumar. So before we move ahead in the webinar, uh, let me do some housekeeping work. Very first, a good news that two of you may win cool goodies which you can see on your screen. So just to win it, you need to participate more, ask more questions, and just be more active in the webinar. Tweet about the webinar and all that. And two of you will have a chance to win this cool Infragistic bag and Infragistic pen drive. We'll announce the winner name in webinar recap blog post, which will be published on Infragistic blog. Uh, uh, then, as always, you will find recording of the webinar with all the resources we are going to use in the webinar in the recap blog post. Two people who will win today will ask you for your mailing address and then we'll courier you the goodies if you are in India. So to win today goodies, you need to be in India and you need to participate actively in today's webinar. So this is the housekeeping. Don't worry if you are not able to catch up today. We are going to post the webinar recap on Infragistic blog, which you can see on your screen right now. So this is infragistics.com/community/blogs, and here you will get that recap blog about today webinar, and in that you will have source code to download, you will have the presentation to download, and as well recording of the webinar. So okay, as of my introduction, my name is Dhananjay Kumar, and I'm a 6 times Microsoft MVP, and I work as consultant for Infragistic. You can send me email regarding the webinar or regarding anything if you need help on Infragistic products or otherwise on debug mode at outlook.com, and I will be happy to help you. So the agenda of today's webinar is very simple. In previous webinars we had a feedback that we went very fast. So today we will be going very step by step and try to be as slow as possible, so that everyone on the same page at the end of the webinar. Today we'll learn about unit test, that why we need unit test. Then we'll see that how we can write unit test using the MS Test. Then further in the webinar, we will learn how to write unit test using NUnit. After that, we will cover a kind of controversial topic, that how to test the private methods. Since morning, I have been talking with industry experts about whether we should test private methods or not. Everyone have their own opinion. Some of them say that, hey, you should never test your private methods. Some of them say that since it is part of the system under test, you must test your private methods. So we'll cover that as well, by assuming that if we have to test the private methods, then how to test it. After that, we'll move and learn about test setup and teardown, which is very important when you start writing unit test. And then at the end of the webinar, we'll create a full-fledged calculator app following the test-driven development or test-first approach. So this is the agenda of today's webinar. So let's get started. Very first, what is unit test, right? Many entry-level developers have this confusion with the word test. When they hear about the word test, they think it is something to deal with the QA team and the testing team. But unit test is something which is related to developer and development life cycle. It is the development process. In unit test, what actually you do, you test behavior of a function by writing another piece of code. So let us say I have a calculator class. Inside the calculator class, I have an add function. And now I want to test that whether I have written this add function correctly or not. I have an option. First, I'll go and create a UI and then enter input, and then I can test that whether add function is working fine or not. But that is not the right approach and optimal approach, because just to test the functionality which you have implemented, you need to create UI and the other stuff which is required to do that. The other approach is that you write another piece of code to test your functionality, to test the behavior of the functionality. And that piece of code is known as unit test. Many people argue that, hey, why we should write another piece of code. My argument, my opinion to them is that writing unit test is like, going to gym. This is extra. This is something which many of us don't enjoy doing that. Like, it is very easy to sit on your couch, watch television, and not go to gym. So it is very easy to wire up your functionality to a UI and start testing that. But as your system grows, having UI for all the functionalities are not feasible. And even if you have a very good UI team, you can have that, but there's a cost involved in that. So the unit test suggests that as you implement one functionality, write another piece of code to test the behavior of that functionality on different set of input, so that you will be very much sure about the functionality you implemented much before that functionality is being used in the real system or in the production. So actually what you do, that unit test is a piece of code which tests behavior of a function or class. And this last statement of this slide is very important. Unit tests are written by the developers. Unit test has nothing to do with your testing team. If you are a developer who is writing a calculator application and you have 4 functions inside your app, you need to write the unit test to verify that those functions would behave as expected whenever you use them. And that is the purpose of unit test. So it is written by the developers. Okay, so let us try to understand that you have an add function. We have already talked about that, but just to put it in the perspective, that I have an add function. What do you usually do? That you pass 2 input parameter to the add function, right? Maybe number 1 and number 2. And what add function does, that it gives you the output, like summation of those 2 numbers. So this is we can consider this is system under test. Now what you do actually is that how you are going to verify that whether when you pass 2 numbers to this add function, it is always giving you the right result. You can verify that much before this add function goes to production or goes as a part of a API or something. You will write unit test to do that. I have mentioned here 2 options. First option is that use function in application and then test it with the application, which is not the right approach, as we discussed earlier, right? Once inside the application, you need to test the whole application maybe in the production, and there are many complexities involved in that. However, the other option is unit test. What you do, you write another piece of code which you will be testing or using this add function to verify that this add function will behave correctly with different set of input, and you will test the behavior of this add function, and that is known as unit test. Great. So why unit test? If you go on internet, like there are millions of articles written that why you need unit test. So I'm not going to again talk the same thing, but I have put it on the slide that some important point that why you should and must write unit test. The first thing is that unit test reduce the level of bugs in the production code, because you have tested all the functionalities much before they go and become part of the production. So the chances of having bug in the code level is minimal if you really follow a unit test. Unit test saves your development time. Like initially it may look that, hey, I need to write another piece of code just to test already the functionality which I have implemented. But as I told you, like it is kind of going to gym. If you go to gym, you don't have to find time and invest your money, or rather waste your money to go to the doctor, right? So this is kind of that. Once you have bug in your production, all of us know that what impact that can bring to the whole team, and in fact to the whole business, right? Because now you have a bug in the bug in the production. But if you have a bug in the development stage, I mean, that is that, and if you are able to identify that by writing another piece of code, actually on the long run you are saving time, you are saving the development time. The other thing is that as you read on the slides, that a good unit test helps you in the documentation. It gives you the scenario much before you go to the production, that in which your functionality may not work, and etc. Now, that was the theoretical part. I'm sure that when you go on internet, you can find many articles which keep talking about unit testing, why you should be doing unit testing, why you should do test-driven development, etc. So I'm just leaving that here, and let us jump to the code and see that how we can write unit tests in .NET. In .NET, you have two options to write unit test. First is MS Test, which is given to you by Microsoft, and another is NUnit, which is very popular, which is from the same family. Like you have JUnit for JavaScript, and sorry, QUnit for JavaScript, and all these so NUnit is part of the same unit family. Uh, both are, I mean, I don't have any opinion that which is better, which is not better. I see it's purely decision of the development team, whether you want to use MS Test or you want to use NUnit. So it's not that NUnit is better than MS Test or MS Test is better than NUnit or kind of thing. I find them equally good. What I'm going to do, I'm going to show you both approach. Like if you have to write unit test using MS Test, how you can do that, and if you have to write unit test using any unit, how you can do that. In .NET, you have these two options. Well, before we go and jump into the code, I would take 2 minutes to explain you that what should be a structure of your test project. I see many people don't follow that. They just write test and they don't follow a project structure for the test. And once your test grows, or once your system under test grows, like that becomes a little bit of a mess. So let us say that if your system under test, ACT means system under test, is a project called calculator, then you will have a class called calculator. Inside that, you may have a method called add and multiply, as you can see on the left side of your screen. Now, if you need to write unit test for that, the naming convention which industry follow, unless until if you don't have any client specific naming convention, or your own organization specific naming convention, then you should follow. So if your project name is calculator, your SUT project name is calculator, then your test project name should be calculator dot tests. The class on the test name is calculator, then your test name for the test class name should be calculator test, without any space or anything. It should be calculator test. Now, if your method name is add, if you want to write a unit test for add method, again, it's purely your choice, but I follow should add numbers. Like when I pass, it should add numbers. So your naming of your test should be as readable as possible, that without looking into the code, if I just read the name of your test function, I should able to identify that what a test this particular function is doing. So this project structure you may want to follow if you are starting new in the test project. Great. When you go to the unit test, you might have heard about AAA, like AAA. What is AAA? Many people talk that, hey, are you following AAA? So AAA stands for arrange, act, and assert. Arrange means first you arrange the things which are required to test the system, test the functionality. Second, that you call that functionality, and third, you assert that whether whatever you were expecting is correct or not. So we'll see that into the demo. Don't worry about that. Great. So to start working with MS Test, let us directly jump to the code, and then we'll come back here again. Again, I will answer your all question at the end of the webinar. So don't worry if your question is not getting answered. Okay, so can you guys see my Visual Studio on my screen? Great. So what I'm going to do, I'm going to follow a I'm going to test a very simple class. What I'm going to do here, I'm going to create a new project, and my new project is a class library, which is let us say a calculator. Okay, and just give me a moment, guys. Let me. So here is my console application. I'm calling it as a calculator class, and then I will go to the desktop and save this in webinar such that I can share with you later. So here I have a calculator class, which is kind of class library, and I'm going to create this. Great. So I have created a calculator class. Okay, and just give me a moment. I'm launching Zoom over here. Great. So it is now working. Yeah. So here I have created a calculator class. In the calculator class, what I'm going to do, I'm going to delete the class which got created by default. And then let me go ahead and add an interface. So I'll say that add new item. And I have, so I'm going to add a class actually. And let us call this class as, again, calculator OP class or something. Okay, so I have a calculator OP class, which is public, and this got two methods. One is public integer add, which takes two input parameter num1 and num2. Great. Then I have one more method here called multiply, and that also takes two input parameter number1 and number2. This has result num1 plus num2, and then we'll say that hey, return this result. This is a very simple system. We are creating calculator application, and we want to unit test it before it goes to the production. So here you see on the purpose what I have done, I have two functions, one add, one multiply. In add, I'm returning, I have implemented it in a right manner. So I'm adding those two numbers which is passed and then returning the result. However, for the multiply, what I'm doing, instead of multiplying those numbers, I'm just adding them. So what we have done here, we have not implemented that multiplication function as it is expected. And let us see that how we are going to test it much before this code goes to production. Now let us say you have implemented it. Line number 18 in your code is wrong. You have implemented it in a wrong way. Great. Now how you are going to test it? Let us say this is a class library, right? And you are creating a WPF application, or you are creating a web API. You will add this reference of this particular library in that particular project and start using multiplication. And you will come to know about this error which you have implemented in line number 18 when you will use this particular function inside that particular application, whether web API or WPF or ASP.NET or MVC, whatever kind of application you are creating. We don't want to do that. We want to verify that whether there's a bug or whether this particular function is behaving as expected or not, much before it goes to your production. So what I'm going to do here, I'm going to show you that how you can test it using MS Test. For that, go to your solution, add a new project, and you have an option of test. So here you see that what I have done, I'm selecting unit test project under the test tab. Okay, I'm going to follow the same standard or same naming convention. Calculator.test. So here I'm giving the name calculator.test because system under test is calculator, the project name. Now I'll say okay. Great. So here you see that it has created a class called unit test 1. We don't need that. We are going to add our own class. So we'll say that, hey, add a new class. And that new class name should be calculator OP test. Okay, so here I'm saying calculator OP test.cs, and inside this class we are going to write all the unit test for the function. Great. So what we need to do first, we need to unit test this add functionality, let us say. So the first step, what you need to do, that attribute this public class under which you are going to write test as, you see here, test class. Okay, and this test class is under the namespace microsoft.visualstudio.testtools.unittesting. Great. Now we want to write a unit test for add, and we can call that as, let us say, public void should return, should add, I'm just giving a name here, should add return 9 when pass 5 and 4. So I'm trying to give as a readable name to my function as possible. So we are saying that add should return 9 when we pass 5 and 4. Okay, so here what we'll do, we need to go and create object of calculator OP. But before that, what you need to do, you need to add reference of system under test. So this is your system under test, this calculator project inside your test project. And how we can do that, right click on your test project, go to the solution and say that add the reference. So here we add a reference of calculator, which is system under test. And now we'll go here and create an object of calculator OP, to say SUT equal to new calculator OP, and then we can say integer result. So here the thing which you are creating, the object of your system under test, this is called as, this is actually arranging the test. So this is your arrange part. Then what we are going to do, we will act now. So in acting means we'll go and call the function which we want to test. We'll say that's sut.add. Okay, and here we'll pass 5 and 4. Okay, and then we will assert here. Now you have many assert functions available in MS Test, which you can read in the documentation. Like you can assert whether two objects are equal to or not, whether some value is under a range or not, whether a particular integer is greater than another integer, and all those things. So you can read that. Here we want a simplest assert possible, that assert are equal, and it takes two parameters, expected and actual. So what we are expecting, so here we need to pass that expected and then the actual value, right? So what we are expecting 9, and the actual value would come in this result. So we'll pass it here. So here you see that what we are doing, we are first arranging, then we are acting, and then we are asserting. Since we are passing here 5 and 4, we know that if add is implemented correctly, the output should be 9. And then we need to make this as test method. In the same way, let us go ahead and should multiply return 5 and 4 when we pass, it should return 20, right? Then calculator app, and here we'll call the mul function. So we have written unit test for both the functions in the calculator class, add function and multiply function. We are expecting that when we pass 5 and 4, it should return 9. When we pass 5 and 4, multiply should return 20. And here we have written the test. Now go ahead and rebuild it. Now to run the test, what you need to do, go to test menu in Visual Studio. Go to test menu in Visual Studio over here, and then you have a Windows option. In the Windows option, select Text Explorer. Okay, I again repeat, go to test, then Windows, then Text Explorer. Here you see that there are 3 tests listed because we did not delete this unit test 1, which got created by default. Let us go ahead and delete that. Now again go and rebuild the test project. Okay, so here you see that now we have these two tests, one which will verify the add function, and another will test the behavior of the multiply function. Now to run that, just click here and say that run all. Okay, so when we click on run all. Oh, so we did a mistake over here. Actually, we are expecting here 20, right? In the multiply function. Right, thank you so much, Vishwanath, for letting me know. And again, let us go ahead and rebuild it. And again, if we go and run this test, you see in the left hand side in the text explorer that it is saying that 1 test passed and 1 test failed. If you click on the failed test, it will give you the information that we were expecting 20, but actual was 9. Now here you can see that much before your test goes, your function go to the production, you are able to identify the bug in your code. And you can integrate this with continuous build server, etc., that whenever a new build in your system under test project comes, the whole test will run automatically, and it will send you a mail, or it will update everyone who is related to the project that hey, a new build has come and a test got broken. So you will be aware that something which we have not implemented as expected. Now to make sure that all the tests runs as expected, let us go to calculator OP class, and here you see that on the add it is saying that we run 1 test, and 1 by 1 means that one passed. But about the multiplication function, it is saying that we ran 1 test and none of them passed. So 0 by 1 you are getting. When you press Alt 3 or click here, it will tell you the region. When you click here, it will take you to the test, that why it is failed. Right, so here even on your system or on your code which you are implementing, you can see that how many tests you have implemented for that particular function, and whether all the tests are passed or not. So let us go ahead here and implement it as expected and rebuild the project. Now come back to Test Explorer and run again, and here you see that all the tests are now green. So this is the basic way, simplest way you can start writing unit test. Now there are some challenges in this particular code. The first challenge what we are doing in the test is that we are actually arranging this object calculator OP SUT, or we are creating object of system under test in all the test functions, which is not the right way to do the things. So you may have a scenario that you want to create all the objects, all the things which is required for your test much before any test starts running. Okay, so I'm going to show you that how you can do that later, and using the NUnit and using here also. So we call them as test setup and test teardown. Test setup means piece of code you want to run before any test start running, and test teardown means piece of code you want to run after all the tests got executed. So you may want to close all the connection to database when all the tests got executed, etc. You'll put that inside the test teardown, and you may want to create the connection to database, or read a file, or create object before any test get executed. You'll put that inside the test setup. Great. Now the last thing in the MS Test, if you want to debug a test, how you can do that. To debug a test, select the test which you want to debug, put the breakpoint first inside the test. Okay, and and then select the test and say debug selected test, and it will allow you to debug the test, and eventually it will allow you to debug the code. So right from the test you can dig into your implemented functionality which you are testing and debug over here. So if I go here and press F11, it will take me to my calculator OP class, which class we are implementing over here, and I can debug them as required. Great. So this is a basic introduction of MS Test. Now let us go and see that how we can do the same thing in NUnit. Okay. So for NUnit, what I'm going to do, I'm going to do the same testing of same calculator OP in NUnit, and I'll put this as num1 plus num2. Now to do it with NUnit, let us create a new project. I'll say add a new project, and that new project should be kind of class library, and let us call it as calculator dot NUnit test. Just I'm giving the name such that when I share this code with you, you know that this is NUnit test code. Great. So here I'm going and creating a class library project. The first thing you need to do is that you need to add reference of NUnit in your test project, and you can do that in various ways. You can do that by using the Visual Studio extension, but I prefer to do to add references by NuGet packages. So I'll go ahead and say manage NuGet packages, and then I'll search here for NUnit. So go to NuGet package manager and search for NUnit. So here I have all the search results. Out of all these, you need to install the NUnit framework and the NUnit test adapter. These two things you need to install in your project. Select and say install, and then select the test adapter and say install. Okay. Once your you have added NUnit libraries in your project, go ahead and rebuild them. Okay. Okay, great. So to start with, what we can do, again here, add a class, the same approach which we have followed for MS Test. Okay, and here, but the attributes names are a bit different. What I'm going to do, I'm going to delete this, or let us rename this, call it as, again, calculator OP test. So here we have public class OP test. Here to make this as a test class in NUnit, you have a attribute called test fixture, which is inside the library NUnit.framework. Let me go ahead and get rid of all these unused namespaces. So here we have added a namespace NUnit.framework. Then to convert a simple class as a test class, use test fixture, and then we need again the method. So what I'm going to do, I'm just going to copy the same function from here. Okay, and but here what we need to do, that again we need to add reference of your project, which is calculator. And in MS Test, you are using test class and test method as an attribute. To create a test class, you use the attribute test class. To create a test method, you use attribute test method. In NUnit, to create a test class, you use attribute test fixture, and to create a test method, you just use test. So here we have now a test test class and function created in NUnit, and exactly we are doing the same thing, but here the assert are a bit different, not as the MS Test. So you can say assert that. So expected result, that is result, is your expected result is equal to, and what we are expecting, 9. Assertion in NUnit is different than assertion in MS Test. So here again we are arranging the test, acting it on, and asserting that. Let us go ahead again and rebuild the project and copy this to test the multiplication also, and we can call this, and then again we'll pass here, and this should be 20. Okay, so again we have written the unit test for calculator OP class using NUnit. You need to just make sure that here you are using test fixture to create test class and test attribute to create test methods, whereas in MS Test you have test class and test method. Great. And don't forget to add a reference of your project, rebuild it. Now you can run our NUnit test in 3 different ways. First is obvious, you go to test, then Windows, and then Test Explorer. Here you see that you have those 2 tests added over here, which you can select them and run all of them. And we are getting the expected output here that a multiplication function is failed because we are expecting 20 and it is returning 9. The other thing is that you can run the NUnit test from NUnit UI as well. To do that, let me go and open NUnit UI. So when you download NUnit, if you go to nunit.org, you can download NUnit UI, and your NUnit UI will look like this on your, as you can see on your screen. Here you go and say file or open project. You need to open a project here. So our project is right now here. Go to Solution Explorer and open folder File Explorer. So our project is actually inside the bin folder. We need this DLL, that calculator.nunit.dll. Let us copy this path from here. Go to NUnit UI, and here we need this calculator.nunit.dll. It is loading here. So here you open the project by passing the DLL of your test project. Just select them, and both of them, if you want to run them, select them, say run, and that is passed. Select another test and run. That would fail, and here you are seeing that error message that that we are expected was 20, but it returned 9. So this is another way in NUnit. You can use NUnit UI to run your test. Again, I repeat, you can download this UI from nunit.org. Once you have downloaded and installed it, go to File, select on Open Project, then browse to the DLL of your test project, select to open that, and then you'll have all your tests loaded there, which you can use. The third option is to run your test using the command prompt. And how you can do that, let us open the command prompt here as admin. Make sure that you are running your command prompt as admin, and then navigate to NUnit folder. It should be inside your program files, or it will depend on where you are installing it. Then you should have inside that NUnit folder. Navigate to bin folder. Inside the bin folder, you should have NUnit -console.exe. Okay, in the double quotes you need to pass again the full path of your DLL. So our DLL is here, calculator in.dll. First select this path from here, go paste that there, and after that the DLL name is this. .dll. So what I am showing you here, that in NUnit you have three options to run your test, even in MS Test also. Here we are running our test using the command prompt, which is very important for you to know. Tomorrow, if you are doing the continuous integration of your test, the command prompt comes very handy. Just go and run NUnit-console.exe, then give the full path of the DLL to run the test. Now when you press enter, this test will run, and here you see that you are getting that one test failed. Expected was 20, but we got 9. So in NUnit you can run a test in three possible ways. Let us switch back to slide for a moment and see where we are right now. So I hope we are going a bit slow today, because it was the feedback from last webinars that we were very fast. So we thought we'll go very slow, and if required for more topics on the unit test, we'll do the second webinar, rather than messing up everything in one webinar, because many people don't get on the same page if we go very fast. So even if some of the unit test topic we are not able to cover today, you can write to us if you are interested, and we will do webinar on that as well, covering those topics only. But our whole purpose is that if you are here for 1 hour, we'll go as slow as possible, that at the end of the webinar all we are on the same page. Okay, so let us back to the slide again. Here you see that when we wrote a test using MS Test, first what we did, we added a reference of BSTS package. We did not have to add that, since we created the project using unit test project template. Then you need to add reference of SUT project. When I say SUT, means system under test. Okay, then we created a test class and the test methods. Then we executed a test using Visual Studio Test Explorer. For the NUnit, what we did, that we added a NUnit package in our test project. Then we added the reference of SUT project. Then we created a test class and test methods. Then we executed a test in three possible ways, like using Visual Studio Test Explorer, using NUnit UI, and using NUnit command prompt. Okay, now let us go to the test setup and test tear down, like how we work with test setup and test tear down. So what happens is that, like right now you see that in all the test methods we are creating object of SUT, which is not right idea. We want to create that object much before any test gets executed, and for that you have test setup. So what happens in test setup, that get executed before execution of the first test, and test tear down means gets executed after execution of all the tests. You may have the scenario like you want to create a database connection, and as we talked earlier are the points here. So let us see that how we can work with test setup and test tear down in MS Test and NUnit. In test setup, in MS Test, to create a test setup, you have an attribute called class initialize, and for tear down you have an attribute called class cleanup. In NUnit, you have attribute called test fixture setup, and you have an attribute called test fixture tear down. Let me show you quickly that how you can do that in NUnit, and then we'll go and create quickly a calculator application following test driven development. Okay, so I see here some questions that that can be checked, can be test the image upload and all that. Always remember, you need test behavior of your functionality into the isolation. Anything which is like you're talking to database or you're talking to file system are not unit testing. When you talk are not unit testing. When you talk to any external thing which is not part of your system, so unit test only test the code and the behavior of the code. If you are testing that whether data got inserted to database or not, it is for me not unit test, it is for me integration test. You are trying to test the integration between your code and the database. Very much we can do that, and many people get confused and calling them as a unit test as well. But unit test is purely on the behavior of the function, like and that also in the isolation of any other system. Maybe in the next webinar, if you want to see that how to work with database, etc., because when you write the code to insert data in database, it may be the chance that your database is not ready yet. In those scenarios, you have the mocking frameworks. You may have to mock the database to do the testing. Rather than calling them unit tests, we can call them integration tests. But I see there are many interest in those topics, and we can definitely cover them in next webinar. Anyway, so let us proceed for today agenda. How we can create a test teardown, and to create a test fixture, what you need to do, just create a method in your code. Okay, and let us call an attribute that with test fixture setup. Okay, and then we can say calculator OPSUT. So now we can get rid of this calculator OPSUT. We can get rid of this arrays in each of the test function, because we have already created that inside the test setup, or we can and the attribute for that is test fixture setup, and then we can use that. Once all the test is done, we want to dispose that particular class object of SUT. For that, what we can say, we'll create a function called test teardown, then attribute that as test fixture teardown, and then we'll make SUT equal to null. And this will make sure that you have object of your system on the test much before you are using them in your test, and it will assure that once all the tests got executed, you have disposed that. I'm not really disposing it here, but you are making them null. Okay, so this is great, guys. Let us jump to the last topic of today webinar, that how we can write a test-driven development, a calculator app using test-driven development. So for that, let me go and add a new project, a class library project, and I'll call it as calculator app. Okay, and when we start doing that, but before we go there, let us jump back to a slide once more. So what you do in test first approach or test driven development, actually you follow this approach: red, green, and refactor. First, what you do, you write a failing test, run the test, and they should be red. So you don't have the system actually in the place. Right now we are going, before we go and implement those add and multiplication functionality, first we write test for that. And since we don't have those functionality implemented, of course the test will fail. So first we'll have the red in our system. So let us first do that. And once you have the test in place, then what you will do, you will go and implement the functionality in the simplest way possible, such that only you will make sure that from the red, your test will become the green. Once that is done, what you'll do, you'll refactor your code. You will clean up the code, eliminate any duplicate code, or any duplication, or any other code smell, and that is the blue part of your code. So actually in the TDD, you follow this approach. First, you write a test without having the functionality, so your test would be red. Then you implement the functionality in the simplest possible way possible. Then and then you make sure that your test is green. Then you refactor the code to remove any duplicacy or any code smell, and then you check in your code to the server. We are going to again take a very simple example here to follow the TDD, and I promise you that in the next webinar we will take much more complex topics to write unit test against them. This is really good. Today we are covering the basics, which we may reuse this learning in the next webinars when we'll target the complex unit testing. Great. So let us say that your in the TDD calculator app, your architect will give you an interface, for example, called iCalculator. Okay, in this interface you have only one function. Let us say add. Just to keep it simple, have only one function. Okay, this is available to us when we started working with this calculator app, and of course we have a class here which is the calculator class. Okay, and this calculator class is public and it will implement that calculator. Now when we start working with this is not implemented. Okay, our system right now in this stage, we have options. Since this is simple, we can say that, hey, I can directly go here and start implementing. No, we don't want to do that. We want to follow the test first approach, and for that what we'll do, first we'll go ahead and write a test for this. And to write the test, let us go ahead here and say that add a new project in this. Okay, and again the test, take the unit test project and let us call it as calculator tdd.test. So you see that we have added a test class over here, and I will again go and probably rename this to calculator test. Okay, and then we have a should add function here. What I'm going to do, I have first we need to add reference of that. Again we are following the so here we don't have system in the place, but we have the project. We'll add that reference in our test here, which is TDD calculator app. Okay, now we'll go ahead and say that create an interface of iCalculator. SUT, and then you can say here that you want that particular method to be I mean, again I'm writing the test setup for your MS test, and how you can write that here, you can go and just say test. Initialize here where we are saying SUT equal to new. New calculator. So here we have put the test setup and we are creating object of SUT over here. And now again I can very quickly go and say that integer result equal to SUT dot add, which takes two parameters. Let us pass 8 and 9, and we know that we can assert. Let me take this from here. Assert are equal 17, right? Now when we run this test, we know that this test is going to fail because we don't have implemented this TDD calculator app 8, right? So let us go to calculator dot TDD test, you see that I have a should add. When I go and run this, of course I'll get exception here because that is not implemented yet. So if you again go back to the PPT, you see that we are right now in this red state, right? So our system is right now in the red. Now we need to make it green. And how we can make it green? Again, go back to Visual Studio here, and we'll go ahead and implement that. So instead of throwing the exception, will say integer result equal to num plus 1 num2, and then return result. Now we have implemented this. When we implemented this, means we are following here, we are trying to make the test green. Rebuild the app, go and run the selected test. You see that our test is now passed. So here again we can go and see that what actually we have done. We made we have made now test from red to green. Since this implementation is very simple, so we don't have to refactor, but if required we can refactor. I understand that we have taken a very very simple example to see that how test first approach should be we can start with, but if you see, this is the objective of today's webinar. We were very clear getting started with unit test in .NET, right? So today we have started with unit test. We understood different component of unit testing, like what is unit test, why unit test. We saw the MS test, we saw NUnit, we worked with fixer setup, Teardown, then we saw the test first approach, and if you want we can talk about the private methods as well. All right, in next webinar, when we do on the unit testing, that will depend on your interest. If you want to see that, we'll go next in that. We'll see that how we can mock an object, how we can arrange the test cases, how we can integrate with this with the continuous build server, how we can do the database testing, how we can do the testing of HTTP request. And I see there are many questions in context of ASP.NET MVC, right? Like whether my controller is returning correct view or not, whether what is the value, how to test temp variable, how to test view bag, etc. So we can do a separate webinar on that how to do the unit testing of ASP.NET controller, and how to do unit testing of CRUD operation using the mocking objects. So guys, I'm done for today. I hope it was useful for you. We worked on your feedback and tried going very as slow as possible today. If you have any feedback, feel free to write back to us. We will definitely work on that. And thank you so much. Now I'll go to the question answer panel and see that if I can answer all of them. If I'm not able to answer all of them, definitely I will put them, take those questions and put the answer on for them for those questions in the follow-up webinar blog on the webinar. Once again, guys, this you can reach to us for any Infragistics query to sales-india@infragistics.com. You can download a trial of all our products. Like if you are working with jQuery or creating web, either using MVC or jQuery, you have Ignite UI, which has all these awesome controls which renders fast, they are responsive, they have all those data visualization things which you can look into, and we have we have control suite for almost all the development stack, whether you work on WP apps, Xamarin, you work on Wave. We have Indigo Studio, which helps you to create your prototype as quickly as possible, etc. So feel free to reach us on given email address, and we'll definitely happy to assist you. And once again, thank you so much everyone for joining today's webinar. And if you have certain requirement for some a specific kind of webinar, feel free to reach us. We'll try to help you. Thank you so much once again, everyone.